Alright, what's going on? So this is my first time seeing this problem, so I'm going to try to record myself live learning how to solve this problem. Okay, so the problem is called delete node in a linked list. Write a function to accept the tell in a single linked list, given only access to that node. Given linked list, oh, my mic's over here. Whoop, okay. Given a linked list head, which looks like the following. Okay, 4519. Accept the tell. So I can delete everything except the tell. Let me create something for me to record what I'm doing. So you can't delete the tell, I guess. So you have 4519, and you say node equals 5. And when you do that, it says you're given the second node with value 5. The linked list should become 4 to 1 to 9 after calling your function. Okay, well, that makes sense. 4, 5, you could just delete node 1. But you can't delete 9 here, I guess. Will not be the till, and will always be a valid node of the linked list. Do not return anything from your function. So, okay. So how would I solve a problem like this? So, this is a singly linked list. So I'll just take a self.x value and a self.next. So self.next is like your next thing. So yeah, so how would I go about solve this? Let's see. 4519. Let's think here. I think that I would, so I mean, to delete a node kind of just means that I'm going to take, so let's say I have 4 to 5 to 1 to 9. So I guess I'm just going to try to think out loud and think on the spot. So let's say I want to delete 5, right? To do that, I would want to basically take the pointer that points to 5, and so I want to take pointer between 4. I want to set 4.next to be .next, right? That's what it seems like. So that's the obvious answer. So like instead of having 4.25, I just say 4.21, which then points to 9, right? Okay, so how do you do that in this program? Well, let's think here. So you have type node, list node, rtype void, do not return anything, modify node in place instead. Yeah, so delete node, and then you have self, and you have node. Set 4.next to be .next. So basically, okay, so it's going to call the node, delete node. Oh, so you're going to be looking at that node. So if I'm looking at 5, if 5 is my input, since it's singly linked list, there's no way for me to. Okay. So let's think about this. So my input node will be 5. Now, if 5 is my input node, how am I going to... I need to basically say that the next of 5... Well, I don't want to set 5.next. Okay, so let's say node 5, and I say, .next equals to none. That doesn't really help, because then we'll still have 4 to 5. And then no point to none. Yeah, So this is the problem that I'm facing right now, and this just might be a lack of knowing this, but for a singly linked list, how can you go in the reverse direction? So like if this is a node I want to delete, how can I go to a previous node? I can't. Like there's literally, the connections only go one way. The only thing I could possibly do is basically start at the head of the thing. Yeah, I guess I'll have to start at the head. So I would say node.head, is that a thing? Or how do I go to the head? It says when you initialize it like so. You know what? I guess I don't really know what the node's going to be. Let's just look at it. So list node value 5. Okay. Can I don't see it. Okay, there's no way this is true because I don't see it being set up here. But I'm just gonna do it. Yeah. How do I? So I'm wondering, how can I access the head? 'Cause I feel like if I can access the head, I can do a linear scan through the list. Just having this node here isn't super useful because like I still need to set the previous node to have this as the next. So I mean, I don't know really how to get around that though. So what else could I try? I could try doing this. Let's print head. I'm gonna say head is equal to list node. This might actually initialize it though, but I don't want to initialize it. I'm just going to check something. Print head. What does this do? Okay, so this initializes a node with a 0 value. Okay, yeah, I kind of suspected so. Yeah, that if I call that, I'm initializing a node. Okay, let's read some more about singly linked lists. Let's read a little more about singly linked lists. I'm surprised that I don't myself personally understand what a single linked list is. Like I was expecting that I would be able to understand what a singly linked list is, but I like, or at least this API, right? This is in the API, and given class list node and definition in itself that okay, I'm gonna think I'll give myself 10 seconds to think. If I can't figure it out, I'll give myself probably more than 10 seconds, but I'm gonna give myself a little bit of time to think. See if I can come up with an idea. What is self? Self would be the object that we are. Okay. So this is an object at this printing you just printed out. Is there a way to it's just an object. Can I'm trying to figure out what are these, if this method even exists. No, it just converts it to a string. Self dot. I'm not sure what I can do with this. Okay, let's go to singly linked list and read a little bit about it. Okay, so here we have a singly linked list. Wow, okay, this is a lot of stuff. I'm gonna maybe just look at the introduction and just see if there's a concept I'm missing. It's a linear data only raise I think we're not storing contagious. Okay. see what it says here. It says if a node be deleted as a root, simply delete it. So I think what they mean there is that I could definitely simply delete it. But to delete a middle node, we must have a pointer to the node previous to the node. So, see if I understand what this means. This might be the wrong thing. Don't look at this. Other stuff on. Okay, this is just for note taking. So it's saying, so here's what I'm thinking. So if deleting head node, like 5 to 4 to 1 to 3, if you're deleting 5 here, you literally just say node dot next equals none, and I would delete 5 and then use a 4 1 3. Okay, but otherwise you need to do this. To delete a middle node, so I'll set it up. So to delete a middle node, 1 3, you must have a pointer to the node previous to the node. So let's say I'm deleting 4, right? So to delete a middle node, we must have a pointer to the node previous to the node to be deleted. It says, so you must have a pointer to the node previous to the node. That's what I was thinking, is that you need to have this pointer here that points to the 4. If positions is not 0, we run a loop position 1 times and get pointer. Sure, but how do I run a loop? Alright. Let's see. This is the position. If link list is empty. Well, they have head here. I don't have head. This is a constructor to initialize the head. Can I do this? Can I do I need to make a constructor? Or, I don't know, I guess I could try that. I thought it was supposed to have everything, but I guess it's the wrong one. I guess I could create something to... Oh no, that's just a constructor because they're going to construct it here, but mine's already constructed. And then inserting at the beginning. Store head node. Position -1. If temp is none, break. If position more than a number of nodes. Oh boy. This is like completely different. The API is completely different. So I feel like to be able to solve this, I need to figure out how I'm going to get the previous pointer. I'm not sure how to do that. I mean, one idea would just be to literally search through every value. Like, I don't know what values these range between, like 1 and, I don't know, 10,000, or it's probably not correct. I probably would have to look. I don't know. Yeah, at this point, I'm giving up. I'm gonna look at discussion and see what I missed. This was easy too, wasn't it? Well, sometimes I guess you don't even know. Some people said this is a stupid question. Interesting. What? We can't really delete the node. That's what I was thinking. But we can kind of achieve the same effect by instead removing the next node. Removing the next node after copying its data into the node that we're asked to delete. You know what? It says instead of removing the next node after copying its data into a node we're using. What? It's so weird. Okay, so here's what I think they're saying. Is that set node equal to node.next. and then I think you just print node. Print node. This is gonna look dumb. I don't know if this will work though. So you have 1 and 9. I don't think that works though. So let's say it says you change the same effect by instead removing the next node. Removing the next node after copying its data into the node that we're asked to delete. So when they mean copy, they mean take the value and set the current value equal to the value in the next node, and then set the node.next equal to the next node. That actually is smart. So I see what they did. So basically you say node.val, so it's node.next.val, val, and then you set node.next equals node.next.next, because you don't want to, you want to go to the next one, but 9. This is such a weird problem. Okay, I get it. Wow. Well, yeah, I didn't figure this out.